1,000 of them. There's a lot about we could learn about the pattern of where these protected areas are established. In particular, are they established to maximize the coverage of elements of biodiversity, in which case the business as usual future might be pretty promising, or are they established for other reasons, more pragmatic reasons? So the first thing we did is gather data on metrics of biodiversity. The first data set is the richness of threatened vertebrates. So we're essentially asking, are protected areas established to cover and protect these vertebrates? Or instead, maybe they are following global guidelines or global maps for where priorities might be for priorities might be for conservation. As you know, different organizations release maps of where they think important places are. So some of these are coarse maps, like biodiversity hotspots or last of the wild. Some are much more fine-grained, like Stu Bouchard was presenting the important bird areas and endemic bird areas. We essentially went out and gathered all these maps that we could get our hands on. We got 8 of them. We overlaid them to create this map. This is showing the number of organizations that think each part of the planet is important for conservation. More pragmatic reasons, this is agricultural opportunity cost across the globe. These are the places in the globe which are good for growing the crops which we depend on. So maybe protected areas are trying to avoid conflict with this major competing land use. We're looking at agriculture only because it's really the biggest driver of habitat loss and therefore the main competitor for land. This is the results from a statistical model, a general linear mixed model, showing the effect of those different potential predictors. What we're seeing here highlighted in red is that cost is really has the biggest effect side, is the best predictor of past protected area establishment. It's a negative relationship, so protected areas are established to minimize cost, so they're avoiding agriculturally suitable areas. There's a weak relationship with conservation templates, driven primarily by maps of wilderness. There's a weak relationship with threatened species, and that relationship is negative. So protected areas are actually avoiding threatened species. So what might be happening here is agriculturally suitable areas are those under the highest pressure, where species are becoming endangered, and at the same time protected areas are avoiding these areas. That looks like what is emerging here. We also analyzed only recently established protected areas to see if maybe this trend is reversing and we're doing a better job now, but if anything it's intensifying. The aversion of high-cost areas in more recently established protected areas is even stronger. So this definitely looks like the pattern of what we tend to do with our protected areas. I should also mention this is in no way a new story. Simon mentioned that we've kind of known this for a long time. We just really want to demonstrate this with finer resolution data than done before to make sure we're doing the right business as usual scenario for our future projections. So that's where we're going next. What does this mean for the achieve 17% target and biodiversity conservation if we follow this similar pattern that we have in the past? So again, we use the planning software MarkSans developed at the University of Queensland. It's used all over the world, as shown by that map there. We're using a lot of the same data sets, same techniques that Stu covered, so I'm not going to cover them at all, except for reiterate that we're doing this global scenario building at the context of nations. So nations have to meet their targets. We know there's no global protected area network. We're talking about national protected area networks. Everything's national in scale, though the maps are global. Okay, so this is our first scenario for the future. This graph, I'll just take a second to explain it. This is showing the ranges of 4,100 odd threatened birds, mammals, and amphibians, their range size on the x-axis on the logarithmic scale, and the proportion of that range in protected areas on the y-axis. Essentially, if a dot for a species is above the red line, we're considering the species to be adequately covered by protected areas using the same targets that Stu used. The first figure A, that's the current network. It's sufficiently covering only about 15% of species. Figure B is our business as usual expansion, aiming to minimize cost and the biodiversity benefits of that scenario. You see species protection goes up only very marginally, only up to 850 species now covered. This is with 17% protection. This is our 2020 goal. Only looking at the area as being the important part of the target. Maybe other parts of the target, like ecological representative, maybe that's important. So that's figure C. This is if protection is allocated evenly across ecoregions. So every ecoregion on the planet receives 17% target, 17% protection, while countries are still meeting their targets. You see very much the same pattern. Threatened vertebrates are still not getting protected under that scenario. The cost does go up a lot. Sorry, the previous cost estimate in terms of lost agricultural revenue is about $5 billion. That's the cheapest way we can meet the 17% target. We do it ecologically representative way. We're talking 25 billion, cost is way up. Species protection is pretty much the same, pretty dismal. Well, you might say, look, Oscar, you're being nearsighted. This is just the beginning, 17%. We're going to keep going and we're going to fix it up later. So that's what we simulated here. This is global protected area expansion from 17% all the way up to 30% of terrestrial areas on the x-axis. And the red dots are showing the increase in cost of that network. You can see the costs start to skyrocket. Black dots are species coverage, still not happening. Still less than a quarter of vertebrates are sufficiently covered. So I think we've pretty much tried every way of skinning that cat. As long as protected areas focus on minimizing cost, we're not going to get threatened species coverage. So we very well might meet the 17% target, and that'll be a flagship result. But whether we do that in a way that meets target 12 at the same time, I'm not sure. We do have one positive thing from our analysis, and that's this. This is the trade-off frontier, or the efficiency frontier, between threatened species protection on the y-axis and the cost of meeting the 17% target on the x-axis. So the beginning point of that curve, that's that cost minimizing $5 billion option that only protects 850 species. What we asked the model to do is minimize cost, but do so in a way that starts to value biodiversity, iteratively, one bit at a time, which brings us up this trade-off frontier. What you see, very much nonlinear, very rapid gains in species protection if threatened species are explicitly considered in the allocation of protected areas or the expansion of protected areas. So that's our good news story. It's hard to tell on the way I've plotted the y-axis, but the number here is 250 species would get protected in the cheapest solution. We can bring that, which is brings global protection up to about 20% of vertebrates. We could go all the way up to 50% of vertebrates. If instead of spending $5 billion, we spend $7.5 billion. Again, these are grain of salt numbers, but essentially a marginal increase in cost leads to a lot more species being covered. Okay, so conclusion, business as usual scenarios don't look very pretty for threatened species. There do appear to be cost-efficient solutions to change that scenario around. If threatened species, if we can get some sort of quantitative targets for threatened species within the overall goal of expanding protected areas. Okay, so thanks to you all for listening. Sorry it was so dismal largely. And a huge thanks to all my friends and colleagues which have contributed to this work and all their institutions. The paper's published in PLOS Biology, came out 4 months ago. It's open access, so feel free to download it and tell a friend.